Digital cellular systems characterized by second generation mobile technology, which characterize basically TDMA and CDMA technology, time division multiple accessing and code division multiple accessing, multiplexing accessing technologies characterized by digital cellular in terms of second generation mobile communication system. The term was given for a new technology that came off from the old analog cellular system for that only focus on voice and data information. But what differs from the second generation analog or second generation mobile systems, digitizing data was introduced into the mobile radio systems in terms of the access multiplexing technologies to give forward to both voice and data information being transmitted instead of an analog form but via digital signal. The access technologies also determine how the digital information, so we're going to be looking at both control and voice channels that are set up in a different way on a digital platform versus analog. And as we spoke about last week, analog technology also had some form of digitizing data, but specifically for analog systems. So there's where we come now with a whole concept of digitizing voice, where this system usually serves several subscribers. In terms of analog, that analog pick up a lot of bandwidth. Digital information actually broke down some of these voice information via compression, which really characterize some of the fundamental characteristics of digitizing the voice, which allows one single radio communication to divide up into several sub-channels, as we spoke about when we talk about the honeycomb structure of mobile communication, which also lends a form of higher security than an analog system, where the analog system suffered from what you call eavesdropping. So we're looking at a subscriber between 20 to 35 subscribers in a specific location, and if you have 8 communication channels, then that 8 will be divided by or multiplied by 20, then multiplied by 32, so you could get a maximum of 4,000 to 64,000 subscribers per radio channel on any given frequency on every given day. In terms of control channels and voice channels, in terms of the two key characteristics of digitizing cellular systems, a control channel on a digital system is use one of the sub-control radio channels, as we spoke about in analog system, but this one is more in a digitizing form, and one or more voice channels that are using a single radio form for voice information in terms of an access. So the portion of the radio channel that is dedicated as a control channel carries only what we call digitizing messages, blank and burst messages, that we will talk about in a little bit. These control channels will also be responsible for competing for access in terms of the mobile communication system. It also be responsible for call waiting and handoff. The other sub-channels on the radio channels is carry what you call voice or data information, which you're going to get into packet data networking in 2.5G GPRS. We are still at 2G technology that characterize both time division multiplexing access technology as well as code division multiple access, which we will explain those two terms in much detail a little later down. Alright, so the basic operations of the cellular systems, as we spoke about before, it requires, or it starts as, it involves first the initialization of a phone when the phone is power on, listening for paging messages. We discussed the whole concept of paging, goes into idle time, and then access mode in terms of conversation mode, whether or not if it's trying to retrieve a call or actually access some call via the DMF tones to place a call. So in initialization, when it's first power on, again it initializes itself by searching or scanning whatever predetermined set of control channels that would have been assigned to it via the visitor location register and the home location register to tune into the strongest one. Hence the reason sometimes when you move from one location to the other, you would find yourself your phone, in fact your mobile phone, and have will take a little while in order to initialize, in terms of the registration process will take place in the VLR, which will determine where the mobile phone is located. But some replication will have to take place first and foremost on the home location register. So during the initialization mode, it listens to the messages on the control channel, hence the reason for the control channel, to retrieve system identification information and setup information, most likely where that will be stored on the home location register. So examining both analog versus digital systems in terms of control channels, if we compare the analog system and digital systems have more communication and control channels because of the fact it's digitized, this can result in mobile phone taking more time to search for control channels on a digital platform versus the analog. So to quickly direct a mobile telephone to an available control channel, digital systems use what you call several processes in terms of algorithm development and so on, and algorithms using math mobile technologies, using what you call filters in terms of bandpass filters, use transform theorems as in Laplace transforms, Fourier series to find the available control channel. This includes having a phone to memorize its last successful control channel. Again, the reason why it is that some people, when they turn on their mobile phones at their home, they find that the control channel is memorized because of the fact that the location register, which is the VLR, has that specific information about the phone, likely on the control mechanism, that will point directly to the operating system, so the phone will tune in much quicker than if it was in a different area all entirely. Hence the reason why it is that we could use this technology to determine whether or not if somebody is in that area or not. For example, I always let you all know in class that you could always track somebody's cellular phone via the VLR, because the VLR would register that particular person in a certain location. After initialization mode, we get into idle mode. After a digital mobile telephone has initialized, it enters an idle mode where it waits to be paged or an initiator call in terms of access, or page in terms of incoming call. When a call begins to receive or initiate, the mobile telephone enters system access mode. We spoke about that in analog systems, and try to access the system via control channel, and the control channel again will be responsible for that. In conversational mode, when it gains access, the control channel sends what we call digital traffic channel designation message indicating an open communication channel. So you'll have what you call a session. This channel may be on a different time slot on the same frequency, or a time slot on a different frequency, according to whatever frequency you tune into. The digital mobile telephone then tunes to the designated communication channels and enter what you call conversation mode in terms of a session between two parties. As a mobile telephone operates on a digital voice channel, the digital system commonly uses some form of phase modulation, and we talk about the different types of modulation as well, amplitude modulation, right? We also talk about frequency modulation, but we talk about phase modulation in terms of the fact that these different types of phases might take place with also taking into consideration both amplitude as well as frequency could be used to send what you call digital information. In access mode, a mobile telephone attempts to obtain service from a cellular system is referred to as an access. Digital mobile telephone compete on control channels to obtain access from a cellular system. Again, we speak about the carrying sense multiple access for collision avoidance because of the competition on the cellular network. Access is an attempt where a command is retrieved or received by the mobile telephone indicating the system needs to service that mobile workstation, such as a paging message indicating a call to be received or a result of request from the user to place a call. So again, this is what access is all about. Understand? The attempt to command or receive the mobile workstation that it needs to be serviced via a call, which is a page, or by placing a call using the DMF tones. Authentication, of course, must take place, and we talk about the whole access, the whole idea of authentication in terms of white hats, grey hats, and black hats. So digital mobile telephones usually have the ability to validate their identities more securely, especially those of the SIM cards, during access than analog mobile telephones. Hence the reason why analog mobile telephones was phased out, because of the fact is that it had so many inconsistencies in terms of people eavesdropping and so on. This is made possible by the process called authentication. Authentication process shares secret data between the digital mobile phone and the cellular system. If the authentication is successful, the system sends out a channel assignment message commanding the mobile telephone to change to a new communication channel, and conversation can begin. Authentication is very important. Again, we spoke about the whole aspect of authentication when we examined the different types of phones that may be misbehaving, or for those mobile telephones that have been cloned, or those mobile telephones that was used for fraud and so on. With these control messages that being sent in digitizing form, sometimes referred to as blank and burst messages, and these control messages also are used for call waiting or for three-way calling, or it could be used for what you call handoff, which we discussed the whole concept of handoff in an earlier class. These blank and burst messages again forms what you call digital information that sends control information via voice signaling. With these voice signaling, it will be there in terms of these control messages to show that some of the digital voice could be sent, while voice information at the same time would be replaced by short blank and burst messages for fast signaling. That is an event particularly like when you want to hand off a particular mobile phone for moving from one location to the next. If you're on a phone call from Port of Spain to Arima, they would have several base station towers that will hand off the call, and these blank and burst messages are used to hand off the call instead of cutting off the call all entirely. In terms of conversation mode, we spoke about the concept of discontinuous transmission, which I'm going to give you all in a story form. Discontinuous transmission is when a person speaks on one end of the mobile phone where the other ones listen for a lengthy period in time. What happened to the person who listens? The phone will assume a silence mode, like if the individual itself came off the phone. Hence the reason why it is that sometimes people will speak and say, hello, you hear me, you're there, is because of the fact that the phone went into a concept of what we call discontinuous transmission. And when you speak, then the phone would light up. This is a way of conserving what you call battery life in transmission mode. Hence the reason a lot of times where batteries normally goes down when two people speak at a time. So you have battery power when you speak, and you have battery power when the phone is in idle mode. Phone is in idle mode may go up to a couple of hours, and we talk about hours in terms of 10-15 hours. When it's in conversation mode, it may only last for about 2 hours if tops. Alright, so with this digital technology, we're looking at some PSTN networks, that is the public switching telephone network, which produce certain up-to-data rates, which has been increased via 4G technology, but we are speaking about 2G technology. We're talking about speech compression. We talk about the algorithms that being used and the bandpass filters too as well. We talk about digitizing the voice that being transmitted across frequency, as well as the switching on the mobile switching center to get connected to the PSTN network. So this is a diagram that you will have to learn for exams in terms of identifying second generation mobile communication, which was introduced both to internet data using GPRS, which was introduced to 2.5G, which is a different diagram all entirely, and the conversation of the mobile switching center to connect to the PSTN network, the public switching telephone network, to transmit basically voice. Alright, so the figure then shows the basic cellular system, the diagram that basically talks about subdivisions of the control channels and digital channels, so both control and voice purposes. When voice channel or voice are transmitted, digital blank and burst messages are sent across. A digital basic cellular system, when conversation is in progress, some of the digital bits are usually dedicated for control informations. We spoke about that in terms of handoff. We have two antenna systems, one to receive a radio and one to retrieve, or one to send, I should say, signals from mobile workstations. Base stations are connected to what you call base station controllers, which is connected to what you call mobile switching center for high speed lines or for microwave links, all which connects to what you call the public switching telephone network system, which is basically analog. So when you characterize two generation systems, you look at first as GSM, IS-36, TDMA, which is the new digital infrastructure for mobile communication that characterized by the use of SIM cards, and code division multiple accessing technology CDMA, which was supposed to introduce by Lactel Technologies in Trinidad and Tobago, but fail in terms of the way how to roll out the system. For advanced messaging system, we use GSM architecture. IS-36 is the name of that architecture, global system for mobile communication, right? That operates on a digital radio platform. Basically, is the operating system that runs on top of TDMA, time division multiple access. And if I was supposed to explain TDMA for you all in one word, we look at TDMA in terms of a train that moving, or a bus or a maxi moving from one point to the next. If a maxi fills up from Port of Spain and it stops at Barataria and it takes off one person, there's a seat that is available for that an additional person to jump on to move from Barataria to San Juan, wherever the case may be. This is how mobile telephone systems work. You have a time slot for each call, and once anybody is not in use of that time slot, then that time slot would be utilized for somebody else to move from San Juan to Barataria, and then if that person comes off from Barataria to Port of Spain. CDMA is a lot different, because CDMA use what you call speed spectrum military information. CDMA, which use not SIM cards, but in terms of code. For example, in an analogical form, if a lot of people in one particular room, and there's one person who speaks a language that nobody else understands, the only person who will understand that particular language, like for example if it's Patois or French, will tune into that particular radio channel. So the thing about CDMA is that the speed spectrum is loud. It could speak to a lot of people, but only if you understand the language, then you will be able to communicate what the person is saying. And hence the reason why this CDMA is very secure, but it's expensive. Alright, so we look at the GSM architecture that first operates on both the 900 and the 1800 megahertz band and the 1900, three different bands. You will know that when you get a cellular phones, you have what you call a personal communication system. You'll normally get a brochure that will let you know what are the bandwidth of the phone, if it's quad or triple, wherever the case may be. And we know about these megahertz channels in terms of airplane technology, which each one of them have to tune into a whole different radio frequency all entirely. So this is how the cellular phones operate. They operate on both those bands, from 900 to 1900 megahertz bands. Some bands would be for control purposes, other bands would be for voice purposes. Some bands will also be used to retrieve, and some bands will be used to send messages. But there's a couple of bands that will be used on the GSM architecture for personal communication systems or personal communication networks on your mobile workstation. Alright, so when communicating with the GSM system, users can operate on the same radio channel simultaneously by sharing time slot because of TDMA, which is the multiplexing technology that is being used on the GSM architecture. So for example, if a cellular system allows 8 mobile telephones to share a 200 kilohertz band radio carrier waveform for voice and data communication, cause what you call full duplexing operation. So it's not a walkie-talkie system, which is half duplex, or simplex, which is just a one-way communication on a normal radio band that was found in frequency modulation. We use simultaneous communication in GSM architecture, so both people could talk at the same time. So some of the features of the GSM system would be to carry, page, coordinate, and to control. GSM digital control channels have more capabilities of analog channels for paging, broadcasting, sleep mode, and so on. And GSM control channels use only portions or one or more slots, typically, which could coexist with your voice channels too on that same specific time slot, using time division multiplexing technology. So again, you will have to know these different time slots for the GSM architecture: one frequency during a voice conversation, and mobile telephones when it's in idle time, and when it is preparing also for handoff when you're traveling from one location to the next. So TDMA IS-36 is otherwise known as the GSM system. IS-36 is the new technology for it. We also have DAMS, which was an offshoot from AMS, IS-54 systems, and the DS AMS in terms of an amalgamation in terms of the evolution of the GSM system for TDMA. The TDMA operate first TDMA analog and then TDMA digital when GSM architecture take over. Alright, so the primary feature of the IS-36 systems in terms of the existing AMP adaptation of bandpass filters, as well as those analog systems that was before, so it could have accommodated backward technology as well as go forward to as well. Move from 30 kilohertz channel on a bandwidth of AMP system. TDMA also occupied what you call AMPS radio units that was there before in the old analog system. Alright, so the IS-36 network, the GSM system that facilitates what they call voice and data communication. Alright, and it could also operate on a single mobile telephone, could also operate on the IS-36 system whenever it is available. But again, in Trinidad and Tobago, we no longer use, as well as in the world, we don't longer use AMPS anymore, which is the first TDMA system, the TDMA analog, and so on. You would recall that a lot of people used to, when they got the GSM phone for SIM, they used to say, you know, people used to be making jokes about, yeah, you're on the TDMA system and so on, not knowing that TDMA is not the frequency. TDMA is actually multiplexing technology that is being used, and GSM just sits on top of it now. Alright, so the IS-36 specification concentrates on features were not present in the IS-54 TDMA system. Again, we spoke about the old TDMA and the new IS-36 network GSM, which include longer standby time, so you'll be able to speak longer. Right, phone calls wouldn't be able to cut off like when I used to tell you all before that phone calls used to be a minute, if so much, and if you go over that minute and you get up to 5 minutes, then you're lucky because you're going into an algorithm of where TDMA time slots used to just facilitate calls that was so expensive, $4 a minute. Right, and it could coexist as well with the public switching telephone network. So some of the benefits of the IS-36 networks, it moved from in terms of it allows mobile workstations to use either 30 kilohertz analog amps as well as 30 kilohertz digital amps. So you have both analog amps that could be used, which no longer being used again for backward technology, and 30 kilohertz digital amps, what was used basically for forward technology that lent to 2.5G and wideband CDMA technology that came on in the third generation. So the IS-36 TDMA radio channels allows multiple mobile telephones to share the same radio frequency via time sharing, and hence the reason why TDMA is very successful technology today. Alright, as we move now to the IS-95 versus the IS-36 network, with the IS-95 is the CDMA network, otherwise known as co-division multiplexing technology, which I give an example of what CDMA is all about, using spectrum radio technology. In fact, they could date back CDMA from the Adolf Hitler time, where they used to send secret messages, naval messages I should say. Hence the reason why it is military applications that use CDMA. So it's only people who tune into that specific radio channel will be able to understand what is the conversation being said. So whether or not if you tune in or not, you may not be able to understand what the conversation is being said because of the fact that TDMA has its own conversation mode. Alright, so the best way to understand CDMA is to think of a room full of people where many conversations are taking place at one time, but each conversation is in a different language. So a listener who can understand the language is able to follow a particular conversation, but to someone who cannot understand the language, it's just noise to them. And hence the reason why CDMA is extremely secure. So we move now to packet data cellular system 2.5G. Why it was 2.5G that introduced GPRS system and edge technology too as well for packet data internet technology. Hence the reason why packet data started to come on mobile telephones using certain technologies like the internet. But the internet again was not fully developed when it was on the GPRS. We've now moved into further technologies called EV video, where you could download an entire video via WhatsApp and so on. But before that, it wasn't that simple in terms of BBM transactions and so on. So the generation couldn't make it to 3G generation, so they went to 2.5G, which characterized some of the technologies of 2G, but it could not have made the third generation technology. Some of the key characteristics of or attributes, I should say, of the 2.5G mobile system is the ability to transport data in packet form, again via what you call the internet connectivity. These systems are usually designed to allow same radio channels to share packet data and voice channels. The add packet data capability. Mobile devices and base stations are modified to include new software that will be able to differentiate between data now and voice. So we had voice and control channels with blank and burst information. Then we have data now for packet data information. So there's a new paradigm shift, a new diagram that has to develop via the switching centers and them to accommodate people who may not be able to go on a voice call but be able to transmit via text messaging and so on, but not in SMS technology. Now, today's technology, we now could use voice over IP to make a call via packet data systems. So you see how technology is developed over a period in time. So this is the diagram here that you would need to learn and understand how the service nodes in terms of the internet data, and we talk about the serving general mobile switching center nodes, so GPRS systems, all right, that will connect to the internet, as well as the mobile switching center using the RAN network that will connect to the public switching telephone network system. So again, the features shows in second generation digital communication system that has been upgraded to offer medium speed packet data, and that was back then because we have packet data that's is been transmitting data into millions of information being transmitted instead of it was just in kilohertz way back then when it was first introduced. Right, so we have GPRS and we have edge technology for both generations of 2.5. You have to know the speeds of both of them. GPRS speeds of 172 kilohertz, kilobits per second, and edge operates at 384 kilobits per second. Hence the reason why it is that it could not have sent a video way back then in both edge technology, right, as well as GPRS. So when we come back to the other slides, we're going to be looking at advanced mobile technology, which introduce now packet data, voice over IP for both third and fourth generation cellular communication, wideband CDMA, and an upgrade of the GSM architecture, as well as the time division multiplexing access technology using the mobile switching center to connect to the public switching telephone network.